We're going to use resistor combinations, Ohm's law, Kirchhoff's current law, to determine I sub 1, I sub 2, and B sub 3. As you can see, from what we have, we cannot get a value for B sub 3, so we need to depend on I sub 2, but we cannot also find a way to determine I sub 2, and so we go back to I sub 1, and we see that we have to do something else. So we're going to start by combining these two resistors into one, and that's just resistors in series. 40 plus 20 is equal to 60 ohms. The next is, now this we will combine it with the 240 in parallel, so 240 ohms in parallel with 60 ohms. This is equal to 240 times 60 divided by 240 plus 60, and that's equivalent to 60 times 240 divided by 300. So if I cancel zeros here and then 3 cancels over here, this is a 48 ohm resistance. So that 48 ohm resistance is down here, and now still I cannot find I sub 1 and I sub 2, so I keep combining these two, and I'm going to combine this into one, and this is going to be a 50 ohm resistance. So now that I have this 50 ohm resistance, I can see that I have these three resistors in parallel, but still I cannot determine I sub 1. So I can combine these two into one, and that is 50 in parallel with 50. This is equivalent to 50 times 50 divided by 2 times 50. And we can see that we can cancel these two, and this will be equal to 50 divided by 2. That's a 25 ohm resistance. So every time we have two equal resistance, this is equal to half of one of the resistors. Now that we have this resistance, 125 and 25 in parallel, still I cannot find a value that will help me determine I sub 1. So I will combine these two into one, and this is going to be 25 parallel 125. That is equal to 25 times 125 divided by 25 plus 125, and this is equivalent to 25 times 125 divided by, this is 150, so it's actually 6 times 25. So we can cancel this, and the equivalent resistance is 125 divided by 6 ohms. So once we have that, we have this equivalent resistance, I can find a voltage. Then I'm just going to call it V sub A. This voltage over here is going to be the 125 over 6 ohms times the 120 milliamps. And you can see that these cancel this, so this is 20 milliamps. 20 milliamps times 125 is 2,500 millivolts. I'm sorry. That's equal to 2.5 volts. Now that we have these 2.5 volts, I know that I'm going to have the same voltage value across the two resistors, since both of them are in parallel. So that means that if I have 2.5 volts and this resistance is equal to 25, I can now determine this current that I'm going to call it I sub x, and I can also determine I sub 1. So I sub x is going to be equal to 2.5 divided by 125 ohms, and this is going to be equal to 20 milliamps. And if you can see now, I sub 1 is going to be 2.5 volts divided by 25 ohms, and this is 100 milliamps. So we have that I sub 1 is going to be 100 milliamps. So we have one of the values that we were looking for. If we move on, now I know that I sub 1 was 100. Now I need to find I sub 2. If you remember, this combination here was 50 ohms, and now I sub 1 is equal to 100 milliamps. And one of the things that we know about currents that flow through equal resistances is that the current I sub 1 will be divided equally because both the resistors are equal. So I sub 2 then should be equal to 100 milliamps divided by 2, or 50 milliamps. So if we expand this further, if you remember, this was 2 plus 48 ohm resistor like that. I sub 2 still is 50 milliamps. And now I need to find a voltage between these two terminals that I'm going to call this V sub B, and this V sub B is going to be equal to 48 ohms times 50 milliamps, and this is going to be equal to 2.4 volts. Once I have this voltage, then I can expand this resistor into the total equivalent resistance that we had before, 48, that was 240, and then this 60 ohm resistor over here. So from here we go back to the original circuit. But we know now that I have 2.4 volts from this terminal to this terminal. That will help me find this current that I'm just going to call it I sub x. So I sub x is going to be 2.4 volts divided by 40 plus 20 ohms, and this is going to give me a current that is going to be equal to 40 milliamps. So knowing that I have 40 milliamps flowing through this branch will allow me to find V sub 3 that is going to be 20 times 40 milliamps, and this is going to be 0.8 volts, and that's the result that we're looking for.